All right, what is up, everyone? We are live. We are doing some live leak coding today, so I'm excited to dig in. I know we've been off for a couple of weeks here, so should be fun to get into solving some problems here. As always, what I'm going to be doing is I am going to be going through one of the recent Leetcode live contests, and we are going to be just working through some of the problems and seeing how we can get to a solution and how we can approach a problem that we've never seen before. Right. This, as I always say, like the number one thing to being successful in interviews and to getting to the point where you're actually able to go into those interviews and succeed is not studying more problems. It's not memorizing more and more solutions. It's learning how to approach these problems and how to solve problems when you haven't seen them before. So that is what we're going to do today. And with that, let's go ahead and jump right in here to we are doing contest 307 today, and we'll go ahead and start with the second one here. Cool. So the largest palindromic number, we're given a string num that consists only of digits, and we want to return the largest palindromic integer that can be formed using the digits taken from num. It should not contain any leading zeros. Okay, so we do not need to use all the digits, but we must use at least one digit, and the digits can be reordered. Okay, so in this case, all right, so we're given all of these digits here, and basically, yeah, we want to generate a number like this that is going to be the largest possible palindromic number, right? So in this case, we have 4 4s, we have 2 7s, we have, okay, so this makes sense. In this case, we have all these zeros, and so the longest one or the largest number would be a 9. Okay, so logically, I think this seems fairly straightforward here, right? So as we're looking at this, let's think about, so a brute force solution to this problem, right? Brute force solution is that we could generate essentially every permutation of some or all of the digits, and we could, and then determine whether they're palindromes or not, and then from there determine which one is the largest number. We could also, because we understand the definition of a palindrome is, you know, a string that is the same forward as it is backward, we could generate a palindrome directly, right? So we could basically say, okay, well, as I'm generating the number, you know, I'm basically building from, I could build from the beginning and the end and sort of say that I'm building a number that is a palindrome. Now, I want to take that one step further because I think that in this case, we want to figure out what is the largest palindrome. And so really, we should be able to generate this directly, right? Because essentially, for a number to be in the palindrome, there are two possibilities. Either the number has to be the midpoint of the palindrome, right? It has to, if like in this example, we have a 9 in the middle, or there has to be an even number of occurrences of that number, right? In this case, there are 2 7s, there are 4 4s, and that allows us to create this palindrome because we have basically every one in the first half of the string has a matching one in the second half of the string. And if we generate a palindrome, we can generate a palindrome we can generate the largest one by basically just taking the largest numbers and decrementing and like basically including the largest digits first and going from there, right? So essentially the largest digits that we're allowed to use or that we're able to use where we have an even number, right? And so what I'm thinking here is I'm thinking that we probably want to, if we just count the number of occurrences of each character, that should give us basically what we need to get started here. So let's start with that, actually. I think that this is going to be the easiest starting point. We have the digits 0 through 9, so I'll just say counts is equal to new int 10. And then we'll just say for and I equals 0, I is, or actually we don't even really need to do that. We can just say for char C in nums.toChar array counts C minus 0 plus plus, right? We're basically going to just count the number of occurrences of each character, right? So in this case, we're going to get, I guess in this case, we would get basically one occurrence of 1, one occurrence of 3, 4 occurrences of 4, etc. So now what do we do? Now that we have this, what I want to do is I think that what's going to be easiest here is rather than trying to generate like the entire palindrome, I'm basically going to generate the first half of the palindrome, and then I can create the rest of my string from there. So essentially what I'm looking for is I'm looking for the largest value that occurs multiple times. I'm going to do this first. I'm going to find the largest value that occurs multiple times. And then once I've done that, I'm basically going to take the even number of occurrences of that. So let me show you what I'm thinking here. And we'll have to make sure that we handle the edge cases as well. Equals new string builder. So here's what I'm thinking. For in I equals counts.length minus 1, I is greater than, well, let's actually, for this, we'll have to handle the case where like our string is only zeros. I'm gonna kind of not worry about these edge cases initially, and then we'll handle them afterwards. So I'm gonna basically say if counts I is greater than or equal to 2, basically if we have at least 2 occurrences of it, then I'm going to add those occurrences of that number to the beginning of my string. And so to do this, I mean, again, there's probably multiple different ways that we could do this, but I'm essentially going to say for int j equals 0, j is less than counts I divided by 2, j plus plus, result dot append we need to, I guess we can just append I, right? As if we append an integer, I believe it should convert it into, we might need to fix this later. But essentially we're going to do that, and then counts I mod equals 2. So essentially, here's what I'm doing, is I'm treating basically, again, I'm only generating the first half of my palindrome. So I'm basically generating the palindrome from the starting point to the middle, and then I'm going to duplicate it. And so that means that for every character that I include, I'm actually using 2 occurrences of that number because I'm going to use it in the second half as well. And so essentially what I'm doing here is I'm just generating that first half of my string. And now all that's left to do is basically find the largest value remaining, and that becomes the midpoint of my palindrome. And if there's nothing, then there is no midpoint of the palindrome. But if we have any characters that occurred an odd number of times, that can still go in the middle of our palindrome. And so to do that, let's see. String builder. I forget how to do this exactly. I want to basically create a string builder, a new string builder that is the reverse of the current one. I can just do I believe that's correct. So now, and then all I have to do now is just figure out, is there a midpoint? So for int I equals counts dot length minus 1, if I is greater than or equal to 0, I minus minus. And then what I'm just gonna do here is I'm gonna say if counts I is greater than 0, what is it? Result dot append I and break. And then result dot append, I think I can, this is basically what I want to do. Result dot to string. So I think this may be syntactically incorrect, but this is just num. All right, so in this case, obviously we did not get the correct answer, so let's see what we did wrong here. Let's make sure that, let's actually print a couple things. So we'll print this array first. Counts. And then we will print result and system out print on reverse. And if we do that, we're getting, okay, so what we're getting, yeah, like this is not, I believe that my concern here is that this is reversing. I think that this is probably resulting reverse in place, and so we're actually getting I think maybe we want to do this and then something like that. Yeah, that's better. Okay. Yeah, because I think what was happening is I think that it just returned. I think that if we call this, it reverses it in place, and then it just returns a pointer to the original string builder, which means that we were basically reversing both of them. So this is giving us the right result here. I believe that this is definitely not going to work for the case where we have these like leading zeros. So like if we had this, it's going to give us this, right? It's going to give us these leading and lagging zeros. And so what we do need to do is we need to go one step further here, which is basically in this, I think in this case, we can basically just check, right? So what we can say, I can just do something like, I'm basically going to check like if I is 0 and the string builder doesn't, if it's like a leading 0, if there's nothing in there yet, then I'm going to break. So it's going to be something like if I equals 0 and result dot length equals 0, then in this case, I don't want to do anything, right? I want to break out. And then otherwise, if it's not a leading 0, I do want to include it. And so that should be fine. Yeah, so that fixes that for us. And then the one other thing, I can get rid of some of these print statements here. The one other thing that we also need to handle here is if our input is just zeros, I think that this is the right answer. I'm assuming that that's correct, but I guess let's just submit it and see. We'll see if we failed anything. Okay, so that seems like that worked here. Let's take a look real quick. No runtime distributions for this. Interesting. Why is that? It seems like that's probably... Seems like it's just bugging out on me. Huh, weird. So I guess we have no idea then how our solution stacked up here, but if we look at the complexity of this, this is there's probably some ways that we could do this a little bit more efficiently, at least code-wise. Like we don't necessarily need this inner for loop, like especially if we were doing this in a language like Python, there is syntax for, appending multiple occurrences of a character or like adding that substring. So we don't necessarily have to do that. But I think with a problem like this, the main things that I would really pay attention to are just, one, this is an interesting example where it's, I think, fairly straightforward how we can generate the optimal solution directly, how there's essentially a greedy approach. But we just have to think about, like, what is it that defines a palindrome? What is it that defines the largest palindrome, right? Like, I did a problem with some of our students the other day that was similar to this, where you're basically trying to generate the largest or smallest number. And so the easiest way to think about that is like, okay, well, the largest order bits are the ones that have the largest impact on the size of the number, right? And so you always want to include the largest values first. And then because we need it to be a palindrome, we know that then it's going to have to be duplicated. Other than this, I mean, I think there might also be... Can't decide whether this is kind of a weird... I feel like this is a little bit awkward, some of this stuff in here. I think the logic is fairly straightforward, but there might be a cleaner way to code this up. I think just it's a little wonky, so not sure. Someone asked, for a junior coder, which language should I study? I agree with the comment. Like, Python is definitely the language that I would start if there's not already a language that you're familiar with. Very much if you are going to do interview prep and you have a language that you already know, you should focus on that language. You shouldn't try and learn a new language for the purposes of your interviews. But if you are learning for the first time, then yeah, I mean, Python's probably one of the easiest ways to get started. And it's also going to be, very relevant for most of what you're going to do. So there's definitely, that's not a bad way to go. All right, let's take a look at the next one here. You're given the root of a binary tree with unique values and an integer start. At minute 0, an infection starts from the node with the value start. Each minute, a node becomes infected if the current node is uninfected and the node is adjacent to an infected node. Return the minimum number or the number of minutes required for the entire tree to be infected. Okay, so in this case, we start with 3, and then after 1 minute, 1, 10, and 6 are going to be infected, then 5, then 4, then 9, and 2. And so we get 4 minutes. Fine. In this case, 1 is the only node, so that's already it's already all infected. So really, with a problem like this, if we kind of rephrase this problem a little bit, basically each step, each minute, the infection spreads by like one, degree of like radius further from the starting point. And so really, the question is mostly just what is the longest path, or what is the longest path from the node, right? What is the longest path from this node in the tree? Because in this case, we see that the 9 and the 2 are the furthest from here, and so they're going to be the last to be infected. And so if we could just calculate that, that's going to be probably the easiest. Now, how do we calculate that? Well, to calculate the longest path, we really have two options. Either the longest path is one of the child paths from our starting point, right? So we could have some long path that goes down below the 10 or below the 6, and that would take a really long time to propagate down. Or it can be on the other side, right? And so in this case, and I guess we could also consider the fact that there could be, even more subtrees too, right? So there are, so it's not necessarily the longest path is not necessarily going to go through the root here. This sounds very similar to like diameter of the tree sort of problem. And what I'm really thinking here is that we can essentially for every node above, we can do a search from this node. Right, so if we find this node in the tree, we can do a search from that node and figure out what is the longest path down below that. Now, otherwise, what we basically need to do is from every node above this node, we could do a search along the other path and see what is basically the longest distance of that path. So let's think about how we might do this. I think that what might be easiest would be to find this node first in the tree, and find the path to this node. Because if we find the path to this node, then that's going to be, I think that's going to make our lives easier. So let's do a list of tree nodes. So what we'll do is this, we'll say, if root.val equals target, then we have found a path. So new linked list, and we'll just add the null.append root and then return result. Otherwise, and actually we should have the null case first probably. So if root is null, return null. Otherwise, we are going to try and find whether it's in the left or the right subtree. So list tree node left path equals path to node root.left target. List tree node right path equals path to node root.right and target. Now, if left path is not equal to null, then that means that that was the path that our node is in. And so we can prepend it, right? So left path dot add, should be add, right? And I believe that the syntax is index then value. It'll certainly correct us if this is wrong. So and return left path. Otherwise, if right path is not equal to null, then right path dot add 0 and root, return right path, and then otherwise it wasn't in either, so we're going to return null. So if we run this, and let's just test this first. So so in this case, yeah, it's not going to tell us what it is, but this should be 2 nodes. So I mean, we can guess that given that this is actually 2 nodes, this is probably correct. So now essentially what we have to do with this is that I want to, for each of these, basically for each of the nodes in this path, I want to do a search in the other direction. And so, like, I'm going to essentially, let me implement a, I'm going to also implement like a depth function. So, return 0, and otherwise we're going to return 1 plus math.max of depth root.left, depth root.right. Like, this is basically going to just find the maximum depth from a given node. So what we can do with this is, now I basically, again, I want to find basically the depth from each node, because that's going to allow me to calculate this. So I'll have for int, and I should really probably use an array list for this. I'm not going to worry about it for now. I equals 0, I is less than path dot length. I'll actually handle these separately. So I'll handle this last case separately. I plus plus. And so what I'm going to do is I'm going to say, basically, I want to traverse the path that is not the one that we went down. So what I need to do is I need to look at the two children of my node and basically see which is the one that is already in the path to the direction that I'm trying to go, and which is the one in the other direction. So essentially what I mean by this is tree node next equals path.get I plus 1, tree node cur, well, this is in the other order. Tree node cur is equal to path.get I. And now what I'm going to, if, so essentially if cur dot left equals next, then I want to search the right path, right? So in this case, I would say I could actually do this even more simply. I'll say that right, so I'm going to do this, and then basically what I'm going to do is I'm going to, so what then becomes the maximum height here? Well, the maximum height becomes, I need to track this max, so max, and then it's height of to search plus path.length minus I. And I think this might be off by 1 here, but essentially what we're saying is, like, this would be like, okay, I'm looking at this node here. I'm going to, it's the distance here, and then it's also the plus the distance to like the depth over here, right? So what I would find in this case is that I is equal to 0, the path.length is equal to 2, and so I would get, and then the height over here would be 3, and my answer is 4, so this should be minus 1, I believe. And I think that that's going to give us, and then the final possibility is, again, that it could just be the height from our final node, right? So that would be max equals math.max of height path.get path.length minus 1. And then again, the height is going to include, I believe it is going to include that current node, so that probably needs to be, the whole thing needs to be minus 1. And then we'll return max. Something like this. All right, so what was that, line 18, line 29. It might be size. Line 22. What are the other ones? Line 29. No. Oops. All right, in this case, I think I didn't, I think I need to put this here. Now, okay, so that gave us a correct answer. Let's see, I don't know that this is going to work for everything, but we'll see. Okay, so we're getting a time limit exceeded here, which is fine. So in this case, let's see how many of the cases we did pass. So we did pass almost all of the cases, but this is going a little slower than we would like it to. And so the question that we really probably want to ask here is, what is the like repeated work that we're doing? And so the real thing that we probably want to do is we could, for example, compute all these depths while we are finding the path to the node. Because what's probably happening here is that we're basically going through some, I don't remember what the exact input was, but we're basically going through the entire tree to find this path, and then we're doing these searches like again and again. That being said, each of these depth first searches that we do to find the depth is going to be non-overlapping, right? Because we're always searching from a different parent node. We're basically searching like, we would be searching, say from here and then from here, which they're not going to be on the same subtree and they're not overlapping. So in that sense, that shouldn't be a problem. The other thing that we're doing that is not great here that we probably want to address is that, again, this should probably be an array list. Not that that's going to just completely fix everything, but just searching, like referencing the index in the array is going to, or in the list is going to be much less efficient. Now, the one thing that we do want to do, because we're doing this as an array list, is that this prepending is not going to be a good idea for an array list. So I'm going to change this, and then what I'm going to do is just reverse this path at the end. I don't know. I think we can probably do this. But let's see. What's the... There, I think we can do collections.reverse maybe. that work? No, it doesn't like that either. I think we're doing it in place, right? So what I need to do is I need to do this first and then reverse it afterwards, right? So I think that's actually what we want to do. Okay. And so to be clear, the reason that I did this was, again, like if we use an array list and we prepend into an array list, think about what an array list really is. It's an array. It's like a resizing array. That is what the data structure actually is. And so the advantage of an array list is that if I say get index in the array list, it's like an array. It takes constant time. But the disadvantage is that, if I were to insert at the beginning of the list, what it has to do is it has to add that item and shift everything else over by one. Now, with a linked list, that wouldn't be an issue because a linked list, it's easy for us to append something to the beginning, but looking up in the middle of the array is going to be time consuming, right? Because we have to scan the whole thing. And so the advantage here is that by appending and then reversing it, I'm avoiding having to shift everything every time. So we're going to get an amortized constant time to add stuff to our array list. And then the reversing takes linear time. So that's going to be more efficient. I don't know that oh, okay. That did solve our problem. I was going to say, I'm not sure that this is going to fix our problem. But this is an interesting case where, this is actually a very interesting case where understanding that underlying implementation can make a big difference, right? Because what was really happening there was just this lookup was taking a long time, and I didn't actually change this at all, right? All I did was I changed from a linked list to an array list. And so if you don't understand what an array list is versus what a linked list is, or if you're using a language where there's higher levels of abstraction, like Python, where you don't necessarily know what's going on under the hood, it can be harder to resolve these sorts of things. All right, I don't know why looks like something's bugging with their distributions here. Because it looks like, this just isn't very helpful, right? Because it's not actually showing us all the information. But I think the one other thing with this problem too is, again, this goes back to understanding what the problem is asking. Because they're wrapping it in this idea of infecting nodes, blah, blah, blah. But really, what is the question? It's just, what is the longest path between two nodes, which we can reduce down into, there are two possibilities. Either it is purely a subtree of that current node, or it is one subtree that goes over to that node and then goes the other way. And so, yes, this code got a little bit involved. This is definitely not the simplest code, but it also logically, I think, is fairly straightforward. So hopefully this makes sense to everyone. All right, we're making good time here, so let's look at this hard one. All right, this one does not have very many accepted. We'll see if we can take a crack at this. We're given an integer array numbers and a positive integer k. We can choose any subsequence of the array and sum all of its elements together. We define k sum as of the array as the kth largest subsequent sum that can be obtained. Return the k sum of the array. So a subsequence is an array that can be derived from another array by deleting some or none of the elements without changing the order. All right, so let's try and understand what's actually happening here. So our nums is equal to this, k is equal to 5. And so, okay, this basically what we want to figure out is the kth largest. So Oh, they're like including this dash here for some reason, which is makes it, I thought this was -6 and I was really confused. So, okay, so we could get 2, 4, we could get 4, we could get all 4, -2, 2 would be this. We could get just 2, we could get 4, -2, we could get, okay, so yeah, and then this is the 5th smallest one. In this case, okay, they're not going to articulate all of them for us because we do have a lot of different possibilities, right? We have essentially the number of subsequences is going to be 2 to the n, right? Because for any subsequence, for each element in that subsequence, it can either be included in the subsequence or not. And so there is so there's going to be 2 to the n different possibilities. Now, obviously, we could go through and we could articulate, we could basically generate a list of all the, for all the subsequences. And if we have we could go through all the subsequences, we can calculate their sums, and then we could sort that list and we could get the kth smallest value, right? We could even go one step further, and rather than generating them all and sorting the whole list, we could use a heap, which would allow us to only store the k largest values. And so that would at least avoid us having to sort the whole thing. Depending on what k is, that could be a lot more efficient. Now, I think that that's not a terrible solution, but given that n can be as large as 10 to the 5, so the number of values, that means that we could have as many as 2 to n to the 5 values, right? Or 2 to 10 to the 5 values. Yeah, so that would be obviously an obscenely large number of different possibilities. K can be, okay, yeah, see, and then k can be anything. Although, oh no, k is not going to be greater than 2,000. Okay. So that does tell us something about for these really large inputs, we only need to generate the 2,000 largest ones. So I guess the question, one question that we can ask is, could we generate all of these results basically? Could we generate these in decreasing order, right? Could we generate all the subsequent sums in order? Now, the other thing actually that's, I think maybe interesting here is that the subsequence, they make a big deal about how the subsequence has to stay in order, but that doesn't actually affect the sum, right? It's not actually the subsequence is kind of a red herring there, because I think that what probably makes sense for us to do is if we start by sorting that array, then it's going to be, I think, relatively easy for us to find, well, certainly it's easy for us to find the largest sum, right? Because we just sum up all the positive values. Or if there are actually, yeah, we sum up all the positive values, and if there are no positive values, then it's 0. Then the question becomes, how do we find the second and the third and the fourth, etc.? And I think that we can maybe do something with essentially, okay, let's look at an example maybe. So let's take this example. And I'm gonna put this in sorted order, right? Because or basically in, let's say, decreasing order. So 4, 3, 1, -2, -10. Because again, the order doesn't matter for the sum. So let's say the largest value we can get is going to be 12 plus 4 plus 3 plus 1, right? So 12 plus 4 plus 3 plus 1 is going to be 12 plus 8, which is going to be 20. Right now, what is the next value? Well, the next smaller one would be removing this 1. Basically we could do one of two things. It's either going to be removing the smallest positive value or adding the smallest negative value, right? If we had, for example, 2 and negative 1, then the next smallest value would be by adding negative 1, not by removing the 2. But in this case, our next one would be 19. Now what's next? Well, next, basically now we have the sum of these ones. What's next is going to be adding back this 1 and removing the 2, and adding back the 1 and the negative 2. And so we would get 20, we would get 18. Now, we probably want to we would want to remove the negative 2 and remove the 3, right? So we would get we would get 17. I'm trying to figure out like what is exactly the rule here though. Like we're starting with the smallest, with basically the values that have the smallest essentially absolute value, right? Maybe another way that we could think about it is basically like, what is the maximum possible value? And then what is like from smallest to largest, what are the amounts that we can essentially remove from that, right? So you start with 0 and then you can remove 1 and then you can remove 2. Oops. And then you could remove 3. Then we could and actually, now that I think about it, there's actually multiple ways that we could get to some of these as well, because we could do we have 20, and then we could remove the 1, which gives us 19. We could also leave the 1 but add negative. Wait, no. Removing the 1 gives us 19. This gives us 8. Removing the 2 gives us 18. Because like maybe what we could do would be even like sort these numbers by like their absolute value essentially. If we sorted the numbers by the absolute value, then we could that would allow us to. It gets weird when we have these negative ones, because it's like with the negative ones, it's non-trivial to me to see how we would combine those together essentially. I think that because like obviously I think that this is I'm not sure that we're going to get something working here in the next, or I don't think we're probably going to get to something working here in the next 10 minutes. But I think that I would guess that what we need to figure out here is some sort of like mathematically, how are we essentially figuring out what the kth value is. I think we certainly want to be able to compute that at least more directly than just generating all of them, right? Now, again, like we could do something. So, for example, let's maybe see how far we can get with a brute force solution here before we run out of time. So, So essentially what I'm going to do is I'm going to generate all the different combinations, and then I'm going to add them to my queue as I go, and then figure out what the sums are, right? So the way that this is going to work, I'll have some private, I guess this is going to be a long, so. So we're going to take in our nums. I'm going to take in an index. I'm going to take in my int k, and I'm going to take in my priority queue. And now what I'm going to do is essentially this is just going to be a very simple like combination problem. I guess I also need to track my like running sum here. If essentially, so if index is equal to nums.length, then that means that we have reached the end here, and so I'm going to add it to my heap. So if heap.size is greater than k, heap.pop, and then heap.add actually no, I need to do this the other way around. So if heap.add sum, and then if this, then this, because I basically want to maintain the k largest values in my heap at any given time. Now otherwise, and then here I return. Otherwise, what's going to happen is I have two possibilities. Either my sum includes the current value or it doesn't include the current value. So find combinations, of nums, sum plus nums idx plus 1, k, and heap. Then the other possibility is that I don't include the current value. So find combinations, nums, sum, idx plus 1, k, and heap. And now all I do is, of course, again, I don't really remember what the, what I really want to do is, I think we just need to pop through everything, right? So find combination, find combinations, nums, sum, idx, or sum, nums, 0, 0, k, heap, and then while not heap dot is empty, really, while heap.size is greater than 1, heap.pop, and then return heap.pop. Right, so if we do this, something like this, it's not pop, it's, I think it's maybe remove. Server error. All right, don't know what that was about. So let's, all right, so obviously we didn't get the right answer here, which means probably, well, certainly means that we did something wrong, but I think that, yeah, actually, I take this back. We should just be returning this right off the bat because that is going to return the smallest value. So if we do that, now we're getting the right answer. Okay, so if we submit this, certainly going to get a time limit. So yeah, this doesn't take us that far in terms of avoiding the time limit. We only passed 34 test cases. Obviously the logic is fine, but the problem here is really that we're generating all the combinations. And so I think maybe what we could do, for example, is like here's so one possibility, and then I got to run here, but one possibility that immediately comes to mind is, for example, we could sort our nums. So we could do like arrays dot sort nums. I want it in reverse order, and I don't remember what the if that syntax is actually correct. But I guess we could do. This is hard when I don't have two screens because I'm sharing my entire screen here. So I gotta look this up on my phone. I think we can use the collections. All right, I guess we probably need to do these one at a time. I don't know. I don't remember what the freaking syntax is for this, but what I'm thinking, and because I got to run anyway, but what I'm imagining here is that we could do, or what I'm thinking we could do is essentially limit our search by trying to not necessarily, we're not necessarily going to go in like order, in the sense of we're not necessarily going to find by doing these combinations the largest ones first necessarily, but it is going to go in some like rough semblance of order, or we could probably change our algorithm a little bit to try and at least include the largest numbers first, and so we could maybe stop our search partway through without going through the whole thing. But yeah, I'm sure there's a better way to do this, and I'm just not sure offhand what it is. So interesting problem. I'll have to explore this one a little bit more. I hope everyone found this helpful. Hope everyone has a good rest of their day, and I will see y'all here next week. Have a good day, everyone.